Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in this lecture. We continue in our unit 3. Today we discuss manufacturing process of our third compound according to our syllabus. Third one is caffeine. CAFFIENE, caffeine. Caffeine is a general purpose food additives. It is food additives and also used in pharmaceutical industry. It is obtained from damaged tea and tea dust. For synthesis of caffeine, there are two routes. One is extracted from damaged tea or tea dust, and second one is chemical synthesis. Caffeine is extracted by this route and chemically it is synthesized. Industrial manufacturing by synthetic route by chemical process. So both are possible for caffeine. So one by one we see these both route, and most often caffeine is in large demand from pharmaceutical industry and also used by soft drink industries. So first of all we see how caffeine is industrially manufactured. Caffeine is industrially manufactured from urea. Caffeine is industrially manufactured by urea by this synthetic route. For caffeine, there are several synthetic routes, and one of them is from urea. We discuss here synthesis of caffeine from urea. NH2CONH2. It is urea. It is treated with CH3NH2. Aminomethane converted into NHCONH CH3CH3. Both hydrogen from urea substituted by methyl group. So we get derivative of urea. Now this derivative is treated with cyanoacetic acid CnCH2COOH. This is cyanoacetic acid. So this urea derivative contains cyanoacetic acid CN. Now this compound is treated with alkali. So cyclization takes place and we get pyridine base derivative. Pyridine base derivative. C double bond O, CH2, C double bond NH, N, CH3. This carbon contains double bond O and this nitrogen contains CH3. So, cyclic compound derivative of pyridine cyclic compound is formed by alkali reaction. Now, we treated this compound with nitrous acid HNO2, nitrous acid HNO2. So here hydrogen is substituted and nitrous group is introduced in parent molecule. So we get nitrous derivative of pyridine. Nitrous derivative of pyridine. Now we takes place reduction unit process. Reduction unit process. So we get amino derivative of pyridine. Reduction takes place. So NO converted into NH2 and C double bond N is also converted into NH2. So we get amino derivative compound. Now this amino derivative compound is treated with formic acid. I rub out above reaction. This compound is treated with formic acid HCOOH, formic acid. So aldehyde group is introduced and we get aldehyde NHCHO, aldehyde derivative. Now this aldehyde derivative undergoes by alkali. Further cyclization takes place and we get caffeine derivative, and with the help of methylation, unit process methylation, methyl group is introduced. Methylation, methyl group is introduced. After methylation, this is structure of caffeine. So we synthesize this by synthetic route from urea. Now we see the extraction process for caffeine from sea dust or damaged sea. Tea waste, most often tea waste contains 3 to 4% of caffeine. So we extract caffeine from sea dust or damaged tea. We draw flow sheet diagram for extraction of caffeine. Digester, filter, dissolving, tank, treatment tank. H2O and tea waste, filter, dissolving tank, we added lead acetate. So albuminoid and tannin remove. Tannin, H2SO4 added. After treatment tank, it is taken into bleacher, then filter, then extraction tank, then still. distillation still. Here charcoal is added. Charcoal CH. Charcoal is added, then filter in extraction tank. Here CHCl3 chloroform is added and waste out material. Then take in distillation tank where chloroform is distilled out, and then it goes into crystallizer. Then centrifuge. And crystals of caffeine. Water is added for crystallization. Removal of water and crystal of caffeine is obtained. From this route we get caffeine. Generally, caffeine is used in food additives and also in pharmaceutical. We discuss here extraction of caffeine from damaged tea or tea dust. Tea waste. Most often tea waste contains 3 to 4% of caffeine. 3 to 4% of caffeine tea waste contains. It is boiled with water. So, in digester, first of all, waste tea and water are boiled and filter when hot. Hot solution is filter off. The hot filtrate is treated with basic lead acetate. In dissolving tank, hot filtrate from digester, and here in dissolving tank lead acetate. Basic alkaline solution of lead acetate is added. So, albuminoid and tannin are precipitated out. From the tea waste or tea contains albuminoids and tannin as a component. So, when we added in dissolving tank hot filtrate solution of tea waste and basic lead acetate, albuminoids and tannin are precipitated out. Now, the clean solution is decanted and treated with sulfuric acid H2SO4. Here H2SO4 is added for remove excess of lead. If any lead acetate is in with solution, then sulfuric acid remove excess of lead. Now, this solution, the clear filtrate, after removal of lead, after from treatment tank, it used in decolorizer or bleacher by charcoal. The clear filtrate after removal of lead is decolorizer by charcoal in bleacher and extract with chloroform. The filtrate is now taken in extraction tank where chloroform is added. So chloroform is extract caffeine. In extraction tank, chloroform is added. So chloroform to extract caffeine. Now chloroform is distilled off in distillation tank and the caffeine obtained is further purified by recrystallization from water and we get crystal of caffeine. Caffeine is large demanded from pharmaceutical industry. In pharmaceutical industry, the demand of caffeine is more and it is also used by soft drink industries like Coca-Cola, Pepsi Cola and other cola drinks. So this is the chemical synthetic route and extraction of caffeine and medicinal and general use of caffeine. Here we complete our third component, extraction of caffeine from tea waste and also a synthetic route from urea. Okay, thank you.